Alrighty. Hey guys, so today we're going to fill out the Thinking with Mathematical Models, problem 1.3, and today's focus question is, how can you predict if a pattern between variables will be linear or nonlinear? So linear does mean if it has a straight line relationship on the graph, and nonlinear means that it does not have a straight line relationship on the graph. When we fill out one of the graphs, this will make more sense. So down here it says, suppose a company called Custom Steel Products, CSP, supplies materials to builders. One common structure that CSP makes is called a truss, as shown in the figure below. It is made by fastening together steel rods 1 foot long. So here we have an example of what 1 foot steel rods look like. And then over here, what 7 foot truss made from 27 rods look like. It says this truss has an overall length of 7 feet. The manager at CSP needs to know the number of rods and any length of truss a customer might order. So part A says, using the drawing above, complete the table below to show the number of rods and trusses of different overall lengths. So if we have we're going to start with 2. If we have 2 feet of truss, we're going to use 7 number of rods. If we have 3 feet, we're going to move up to 11 number of rods. So from here, I need to find a pattern. To go from 7 to 11, I know that I am going to add 4 rods. Let's see, because it says later on in the table, 7 length of feet of truss tells me that I need 27 number of rods. So let me think, or let me check to see if my pattern of adding 4 each time will work. So I'm going to plug in all of my different values by adding 4 each time. So 11 plus 4 would give me 15. If I add another 4, I should have 19. Add another 4, I should have 23. And if I add another 4, I do get to 27 rods. So my pattern is adding 4 rods for every single foot. So I'm going to finish off the table by adding 4 more. And I should end with 8 feet of truss. I should have 31 rods making up the length of the truss. Number 1, it says make a graph of the data in your table. Label your axes and number the axes appropriately. So on here, the axes are my X and Y axis. So my X, which goes left and right, is going to be the truss feet. Actually, I'm going to bring that down just a little. So truss feet. And then my Y is going to be the number of rods. Since my table is counting my X's, is counting by 1, that's also what I'm going to put on my X's. So I am counting by 1, but I'm going to label every 2 just so I can save myself some room. I'm going to go all the way up to 10. On my Y's, since I'm counting, or my pattern is counting by 4s, I'm going to also count by 4s on my number line. So I start at 0. Every line is going to be worth 4, but I am going to skip. That way all of my numbers are not crunched together and it looks more organized. So I'm going to label every 8. From here, I need to go ahead and label from my table. So my first point is going to be 2, 7. So I go to the right 2 and I go up 7. Because I don't have actually a 7 on my graph, I am going to estimate. So I'm going to put it as closest to 8 as I can without actually going on the 8. And then I continue from here. My next one should be 3, 11. So I go over 3 and I go up to where I believe 11 would be. and then I continue the pattern. I go over 4, I go up to 15, I go over 5, I go up to 19, 6, I go up to 23, go over 7, and I go up to 27. And the last one I go over to 8, and then I go up to 31. So all of my dots are barely underneath of where I've marked on my y-axis. And then I'm going to go ahead and connect them with a straight line. Make sure that when you are making your graph, your arrow should be on the end of your line because that signals that you can continue on with this pattern. Number 2, describe the pattern of change in the number of rods used as the truss length increases. So every time the length increases by 1, the number of rods will increase by 4. Okay. I'm going to go ahead and scroll down to number 3. Number 3 says, how is the pattern you described shown in the table? How is it shown on the graph? So on the table, you see that you increase in the length of the feet by 1. Your bottom row increases by 4. So table, which we have already said this, but we're just going to rewrite it. So length increases by 1. Rods increase by 4. On a graph, each time that we were plotting our next point, we were actually going over 1 on our x, and then we went up 4 on our y. So that's how we got from each point next to the next one on the graph. So on the graph, we're going to say move 1 Actually, there is a better way to say this that requires us to write a little less. Move over 1, go up 4. And then last one for part A. How many steel rods are in a truss 50 feet long overall? Explain how to find this number without drawing the truss. So what I can do is I can actually go back up to my table and continue my pattern, and my goal is to want to get to 10 feet long. If I go back up to my original table, I'm going to add just a couple of boxes. And I'm going to fill in 9 feet and 10 feet. If I continue on with my pattern of adding 4 rods every time that 1 foot increases, if I have 9 feet, I should have 35. And then if I have 10 feet, I should have 39. Since my goal is to get to 50 feet, I can actually take the 10 feet and multiply it by 5. Let me go back down to my question. So I can take the 10 feet and multiply it by 5 to get to the 50 feet. And I can take the number of rods, which were 39, and I can multiply it by 5. When I do 39 times 5, I should get 195. But I do need to include that 1 foot at the very beginning. It was not part of our table. So we know that every 1 foot of length is actually 4 rods. So because I want to add the 4 that it started with, the total is 199 rods. And that is it for part A. Part B. Custom steel products also make staircase frames like those shown here. So one step has 4 number of rods, makes a square. When you go to 2 steps, you keep the original 1, but then add 1 on top and 1 in front of. So you're building a staircase. So if we look at number 1, it says complete the table below to show the number of rods in staircase frames with different number of steps. Okay? If we go and look here, each time that we're adding 1 step, we need to find a pattern. From 1 to 2 steps, it looks like we went from 4 to 10 rods. I know that is a plus 6 increase. From 2 to 3 steps, it looks like we increased by 8 rods. So my guess is I'm going to continue with the pattern of adding the next even number. So 6, 8, that tells me I should add 10 as my next even number. So 18 plus 10 does give me 28. If I add 12 next, I should have 40. Then I add 14, which should give me 54. Then I can add 16, and I should have 70. And then lastly, I'm going to add 18, and I should have 88. So number 2, we need to make another graph of our data. We need to label our axes and number the axes appropriately. So if I come down here, I want to label my X first. I'm going to label that as the number of steps. And then my Y is going to be the number of rods. Since my number of steps are counting by 1 or increasing by 1, that's also what I'm going to do on my graph. I'm going to do the same thing as I did last time. I am going to count by 1s, but I'm only going to label every 2 just so that it saves me some space on my graph and not everything looks so compacted and squished. And then for my number of rods, I'm going to choose an even number, and I'm not really consistently changing by like the same constant. So I'm just going to pick 20s because I think it's a well-rounded number, and plus it keeps us on that even track since all numbers in our number of rods are even numbers. So I'm going to count by 10, but then label every 20s again, so I'm not that crunched and not everything is compacted. To get my first point on my graph, I need to go to 1, 4. So down here, I'm going to go to the right 1 square, and then I'm going to go up to where I believe 4 would be. Every line is going to count by 10, so it should be a little under halfway. Again, we are estimating, we are doing our absolute best. Our next point is 2, 10. So I go to the right 2 squares and I go up to where 10 is on my graph, and it's going to be right here. I go to the right 3. I should go where I believe 18 is. So I'm almost at the 20, but I'm not quite. So I'm going to go a little bit below. For 4, I'm going to go to the right 4. I'm going to go up 28. So again, it's like a little bit below where 30 would be. We are estimating to the best of our ability. I'm going to go to the right 5, go up to where 40 is. Going to go up 6, and then I'm going to go up to where 54 is. Go to the right 7, going to go up to 7D. And then our last one is 8, 88. So I'm going to go to the right 8, and I believe it should be right under 90. What I would like to do is I would like to connect the dots. Now, the dots are not in a perfect straight line, and that's actually what we wanted because it's going to describe this kind of different relationship. So if I do, I should not connect them with a straight line. I should actually connect them with a curved line. So there is my curved line. It does not have to be perfect. Okay, that's in our number 2. Let's go ahead and scroll down to number 3. Describe the pattern of change in the number of rods as the number of steps increases. So the pattern of change in the number of rods is it increases by the next even number. So I'm going to go ahead and zoom in on 3. So as the steps go up by 1, the rods increase by the next even number. Number 4 is asking, how is the pattern you described shown in the table? How is it shown in the graph? So on the table, we actually wrote down our pattern. We did test it. It is the next even number. Sorry, my pen just randomly turned off. So here I'm not going to write out all of the different changes. I am going to put 6, 8, and 10 since those were our first ones. And then I'm going to put 3 dots to show it does continue. And then how is it shown in the graph? So I'm going to put T for a table next to the first sentence that we wrote. And I'm going to put G for on the graph, it actually curves upward at an increasing rate. So notice how it's not constant. So the first one was a straight line because it was constantly increasing by the same number. This one is increasing by the next highest even number. So the dots actually go up in a curved line. So we're going to write the graph increases at, actually I'm going to say the graph increases by a curved line. Sorry if I seem really distracted, kind of am. Fester is just running around here, acting crazy. So I keep looking at my iPad, making sure I'm writing the right things, and then I keep looking back at him. So again, I am so sorry if I seem totally spaced out. My full attention is not fully on this video. Again, I apologize for that. But we are almost done. So number 5 says, how many steel rods are in a staircase frame with 11 steps? Explain how you could find this without drawing the staircase frame. What we could actually do is go back up to your original table, which we are, and we can just continue the pattern. So if it wants 11, I'm going to draw 3 more boxes on. Here is 9, here is 10, and here is 11. We left off with by adding 18, so our next number that's going to happen is we're going to increase by 20. That's going to get us to 108. Plus 22 is going to get us to 130. And then our last one is plus 24, so we should be ending with 154 rods. So the answer to number 5 is continuing the pattern. And the answer, or in the number of rods, is 154. Alrighty, last 2 questions. Let's go ahead and get this done. Part C, how is the pattern in problem 1.3 part A similar to the pattern in problem 1.3 part B? So how is the pattern related in the first part of this notes versus the second part that we just completed? How are they similar? How are they different? So I'm going to go ahead and cut this area into 2. I'm going to put similarities on the left. So I'm going to put sim. On the right, I'm going to go ahead and put difference or diff. Similarities, they are both increasing. So they do both increase. And this is from left to right because that is how we read graphs and tables. They are different by part A was a straight line. Part B was a curved line. Another thing that was different was in part A, we were adding by a constant, which is just adding the same number every single time in our pattern. In part B, we were increasing, but it was not a constant number. So I'm going to put A, increase constant number. Then I'm going to kind of scroll down in part D a little bit because I ran out of room. Increase, not constant number. Alrighty. Part D, so now we're going to go ahead and relate it back to Tuesdays and Wednesdays notes on the bridge thickness. So when we're comparing the patterns of change in this problem, now we're going to compare the patterns in problem 1.1 and 1.2. So Tuesday's notes versus Wednesday notes. So in Tuesday's notes, both relationships, they are increasing and they both are linear. Nope, just kidding. I was right. It says compare the patterns of change in this problem with Tuesday and Wednesday. Again, I am so sorry, people. I appreciate all of your patience. Again, Fester is just completely running around the house, and I am just trying to keep him corralled. So last question. So the patterns are, we are increasing here as well as we are increasing in the other notes. So we are increasing. on table and graph. Okay. And then the bridge length and the staircase relationships are both nonlinear. This just means that they have a curved line on their graph. It is not a straight line. Once you are done writing down all of the notes with me, again, I thank you all so much. I apologize for any kind of spaciness that I have. Got a wild kitten running around here and just trying to keep him corralled. But please go ahead, take a picture of these notes, submit them on Canvas, and now you're going to go ahead and work on the practice 1.3 worksheet. This can be found on Canvas. It also has a paper copy that you can ask for from the sub. Thanks, guys, and I'll see you all tomorrow.